All right, so your lab report, you've had, let's talk about this lab report. Please take out the template that I gave you. Could someone give me a copy, because I gave the last one I had up on my desk. Thank you. So number one, on this lab report business, you will have had 1.5 weeks to do this. It should have been done. Anybody who missed the lab, you had opportunities after school to make it up. And before school. And the kids have come, and 3 students took advantage of that.
I ain't know, for real. If you want, I ain't know.
If you did not do this, if you didn't, and you still missed it, just get the data. So that you can finish your lab report. If you are waiting till now to start this, wow, that's real sad. Because like I said, you had a week and a half. And you're planning on doing it this weekend, and you feel stressed. And some of your parents are going to call me and say, wow, my kid's really, really stressed out over this. This is a lot of work. I'm going to tell them, hey, I gave them this assignment a week and a half ago. And I've been here after school, and I have assisted now 5 students in completing their lab reports. So they've completed it. They're done. They're waiting for me to create the assignment in Turnitin.com so they can submit it. I've already read I've read their notes. I've said, yeah, that's a good idea. That's a good idea. No, I would change this. I would change that. We've worked together on this after school. Some of you have chosen not to do this. That's okay, but I'm going to say it again. I've said it many times during this week and a half. I am grading this lab report very strictly. It's going to be a rigorous examination of your abilities and of your knowledge of osmosis, diffusion, and the scientific method. So if you don't do a good job, it's not going to be a good grade. There is no curve on this. So understand that. It's going to be strictly based on the benchmarks that we have discussed. So now, that being said, let's go ahead and begin. I'm going to give you time today to do this. I'm going to explain one more time what needs to be done here and now, and then the rest of the period you'll have to do it. So that's the other thing I should add to this list of what have we done to prepare you for this. I am giving you a period, 1 class period, to get your information together. And really finalize your draft. So your draft is handwritten, but remember, you have to write it up in either Microsoft Word or Google Docs.
Write it up, type it up, same difference. Yes, it is.
Yeah, write it up, type it up. I don't care how you want to say it. So everything that you're going to write is going to be done in one of those formats, and you must put into place in your lab report graphs and data tables and and pictures or drawings. All right, somebody asked, can I just, instead of drawing it or sketching it, can I just take pictures of what we did? And early on, I said, yes, go ahead any way you want. But where it says sketches, you're going to put some sketches or pictures or whatever it is that you want to do. Now, if you have problems with it, you don't have a camera, a phone with a camera, whatever, ask a friend to take pictures of the setup or of your drawing and email it to you, and then you put it into your Google Drive, and you can access it that way for your Google Doc. However you want to handle it, but you have to get this type. It's a matter of fact. So the first part of this is your background, and what am I looking for in your background? Could someone close the door? In your background, it's quite simple. You need to describe, and explain the processes of osmosis and diffusion. I mean, just make sure you go through every step of what you know, anything you know. We've discussed it in class. You've gotten practice questions. We've done a lab. I mean, at this point, you should know a lot, and there should be a lot in your notes on it. Secondly, make sure, as part of this discussion, make sure you're talking about what happens when the solute does not pass through the selectively permeable membrane. In the case of this lab, it's going to be a dialysis bag, and then what happens when it does. Please make sure you talk about the membrane, the dialysis bag. That you created. How does it work? How did dialysis, it is a selectively permeable membrane. If you remember our discussions, this is a selectively permeable membrane. So what does it allow through? Just to make sure you make it clear that it does not, NaCl does not pass through the membrane, and glucose does. So you should be able to describe all that in the background in a paragraph form. Somebody said, well, can I write it in a bullet form? No, this is to be a paragraph form. You have to write it as if you're explaining something. You're explaining, right? You're explaining to somebody who's never heard of it before. This is diffusion. This is osmosis. You're writing something that should be able to be published. I should be able to say, oh, let me just print this and put it up on the wall. And anybody who comes into the room should be able to say, hey, these kids know what osmosis and diffusion are and how they work. You should be talking about passive transport. You should be talking about passive transport. You should, in other words, what do I mean by passive transport? Of course, moving from high to low without any extra energy, right? So, as long as you're doing that, your background will be solid. The better you write, of course, the better your grade on the background. Each section is going to be worth a different number of points. I will publish the rubric for you this weekend. It's not due till Monday, but you should have this part, honestly, a week and a half ago. Last weekend, you should have written this. This should be done. Because you didn't even need the data for this, right? The next is experimental design.
That's old.
In experimental design, you're going to describe your three main groups. And I made a mistake in the experimental group. I put I put experimental group twice, and that was a mistake. Two of the groups are experimental groups. Please correct that. The third group is the control group, correct?
Yeah.
All right, so that was a mistake. Make sure you fix it in your document. So you have two experimental groups. Two groups that you're looking to try to see if you can identify the phenomenon, to see if the phenomenon is acting the way you think it does. And the one is hypertonic. So and I'm going to draw it, but you're going to describe it in a paragraph, right? You're not going to draw it. The sketch will come later. But hypertonic, you made a little baggie, right? And it's hard to draw it far away. Let me zoom in. So you made a little baggie, and in that baggie was salt water, NaCl. So that's what made this solution hypertonic. And here was distilled water. And you guys can talk about what that means, right? And maybe in your background you talk about what, you describe whatever it is you want, but make sure in your background you talk about hypertonic and hypotonic. That's part of osmosis, right? You have to describe what happens when something's in a hypertonic solution. In which way do you expect the water to go, right? And you want to describe that you expect the mass to blank, right? And you're going to measure the mass using a triple beam balance and all that. So here you're describing in your experimental design, what you're doing is you're describing what are you doing? How are you setting up this experiment so that you can see the relationship that you described in the background? Yes.
In our background, can we include the overhydration section of osmosis?
You can, but I guess you can describe that as well if you want. But really, the key to the background is you want to give the person who's reading it enough background to understand your experiment. So if your experiment has something to do with overhydration, that's fine. If it doesn't, it might be a little too much. But you can. I've seen plenty of backgrounds that kind of try to address why is this experiment important? What does this experiment have to do with life? So overhydration is something that high blood pressure is another example you can talk about where this process comes into play. Digestion and absorption of nutrients, malabsorption of nutrients. These are all places where osmosis and diffusion can be applied, right? So yeah, I could see you writing about that. That would be excellent. You're going above and beyond if you're shooting for an A+ on that one. But you have to include all the other stuff as well. Don't focus on a hyperhydration and then not mention hypotonic, hypertonic, and isotonic, right? Like you have to get the basics first and then go ahead and do your extensions. All right. 2. By the way, this is the most common mistake when students write. You contradict yourselves. You contradict yourselves. You say hypertonic is this, and then later on in your lab report you say hypertonic is that. It can't be both. You can't tell me that it should lose. You can't talk to me about I expected the dialysis bag to decrease in mass because water's leaving, right? You can't tell me that that's happening. Then you show in your data that the mass is increasing, and then in your conclusion you say I was right. Well, what? That doesn't make sense. It has to flow. Whatever you're saying has to make sense. You're not just writing for writing's sake. You're actually writing to describe what's happening in your lab report, in your lab. What happened and explain it. It's okay that the mass increased. You measured the mass and the mass increased. You expected it to decrease. Okay, fine. Now say that. Say, I expected to do this, and this is what happened. Now, why? Why did that happen? Don't tell me that the bag should have lost weight, should have lost mass. It should not have lost mass. Why did your bag seem to gain mass? I mean, don't tell me it should have gained mass. It shouldn't have gained mass. It should have lost mass. But why did yours seem to gain mass? It could have been a lot of different errors on your group's part, correct? But you have to describe that. What do you think happened? Well, I think we measured the mass wrong. I think we put the wrong solutions. I think we put it in hypotonic. I think we reversed the solutions. I think we put the hypertonic solution in the bag and the hypotonic outside. Or whatever you think happened. I don't know. But explain, whatever results you got, your explanation, right? Remember the things we talked about, right? I see your hands. Give me a second. Remember we said claim, right? Evidence, and then reasoning. You have to have, your claim has to be supported by the evidence. Your evidence can't contradict what you're saying. And lastly, you have to have logical reasoning. It has to make sense. It has to be logical. That one thing has to be built upon another. You can't just make some wild claim and not be connected somehow to your evidence or your reason. And the reasoning has to be connected to both the claim and the evidence. Does that make sense? Am I making sense to everybody? Yes, question. Go ahead, ask your questions. I don't want to say your names and I'm recording. Go ahead.
So, could it because our thing got bigger, so could it be because we measured one of them was yours and then that day was when we had to measure that one?
That could be. It could be there was something wrong. Now, the problem with your thinking, with your suggestion, it's a good thought, but the problem with that thought is that if you use the balances correctly, you should have zeroed the balances first. And if you zeroed the balances, then they should work. Also, we had electronic balances that a lot of people measured them both on a triple beam and the electronic balance. And by the way, you should mention that in your experimental design if you did that, because that way you can say we checked our masses, right? We double checked that we were doing it correctly. Yeah.
What could be other possible errors in the
Let's wait on errors when we get to error discussion. But yeah.
for last week on Friday, we didn't measure, so we don't have nothing for the fourth day.
That's okay. Whatever you have, that's what you grab. Whatever you have, that's what you use. If you only got one group only had 2 measurements, fine, right? But when you get to the averages, you should have at least 3 different groups data, whatever that means. So I know a lot of groups did all 4 days. Some groups got 2. Some groups got 3. One group had 5 days. One student who missed the lab has a whole week's worth because they had the weekend, and then they did it 2 more days after that. So how many days is not really the point here. It's really is just that you're making a claim that's based on evidence and you understand the process. Then we're working towards our success. Then your hypotonic solution. And in the hypotonic solution again, oh, thank you. You have, oh man. So in the hypotonic solution, looks like a really ugly turkey breast or turkey leg. But anyways, in the hypotonic solution, remember we have the water, and it's in distilled water, and inside here you have glucose, right? Yes. Now glucose passes through the membrane. So normally, and this is what I've seen, this is the correction I've made with several of the groups that came after school and discussed it with me. Normally, in a hypotonic solution, you would expect the distilled water to rush in. That is correct. If the solute doesn't move out, right? But in this case, we know what? The glucose moves out. We know that. How do we know that? We tested the water, and that's part of your design, right? That's part of your experimental design. You were going to use these glucose sticks that are in a hospital, they're used to measure the glucose in urine. You were going to use those to measure, see if there's any glucose in the water. There should not be. If there was, that means glucose passed through. And I'm going to tell you right now, everybody can write down in their results, because we tested all the water for you. There was glucose in the water, in everyone's water. Afterwards. After 1 day. So we know that glucose went across. This should be in the results, by the way. This should not be here. Are we clear on that?
Yeah.
I'm just telling you now, you can write it down, but that should be in your results section. The glucose did cross the membrane. So because the glucose crossed the membrane, did you expect there to be a net movement of water across the membrane? Yes or no? No, not really. You expect there to be a lot less mass change. Less mass change. So what should happen? What would happen? What do you expect to happen? I mean, you just described what you know. You know the glucose is going to move out, so you're probably going to lose a little bit, right? Small amounts of mass, right? Some small amount of mass is going to be lost. Why? Because glucose is going to move out. Correct? But water won't really change that much. The glucose is going to equilibrate, and you'll lose some mass. So if you lost mass, some kids were really confused. We went down a little bit, and it didn't make sense to them because the kids that we talked to in class, and then again after school, in the hypotonic, I expected it to increase mass. I said yes, but only if the glucose did not move across the membrane. But based on your data, the glucose did, so there's not going to be a big change in mass the way we did see in the hypertonic solution. And our control group was our isotonic, our group 3. And there was just distilled water with distilled water. So there really shouldn't be any change, right? So here, if you see any kind of change in mass, then you know something went wrong. Correct? This is where you test to see if your balance. Who said something about you switch balances? All right, so you guys mentioned that, right? So then you ask yourself, well, what happened with the isotonic? We switched balances. We measured the isotonic on 2 different balances as well. Did we get a big change in mass? If we did, then maybe something is wrong with our balance, right? So consider that. If you didn't, if your isotonic was relatively the same mass on each of the measurements, but your hypotonic changed, now you got a problem. Now maybe you're not consistent with your measurements, or maybe you put the wrong liquids in there. So there's some issues you have to explain there. But isotonic was just simply distilled water and distilled water. There really wasn't a lot really to discuss there, except that it was really used to see if your measurements were correct and were your solutions correct. If you knew what was distilled water, what was not distilled water, then you should be fine with that one. Also, it allowed you to calibrate and seek. It allowed you to calibrate and seek. That's part of the experimental design. That the differences in mass for the control group from measurement to measurement right, helps us know how accurate and how precise our measuring was. Is that right? We talked about precision and accuracy. So when you're looking at the measurement, how close, so if, for example, our measurements were plus or minus 0.4. What do I mean by plus or minus 0.4? On one day it was 6, another day it was 6.4, another day it was 6 again, the last day was 5.2, or I'm sorry, 5.8, right? So that's within 0.4 of either side of 6. Then the difference
That's a plus, right?
yeah, this is plus, and then there's a minus underneath it.
Oh.
Plus, minus. Is it better to put a slash? Would you rather be more comfortable if we did it in a different way, rather than writing? That's normally the way we write it, but you could put plus slash, right?
Yeah.
Plus slash minus. Right, this way if you'd rather. Then the difference, observed is insignificant. Because that's telling you how precise your measurements are, right? This is as precise as I was able to get it. I know that the mass should not be different, but for some reason the bag was wet outside on one day, it was dry on the next. Or maybe I don't know. I'm not quite sure how to use a triple beam balance, or maybe it was really high pressure day, or something happened where there was a slight difference in measurements. The differences in measurement due to things other than the change in the mass of the bag was 0.4 plus or minus 0.4. Does that make sense? That's what a control group is used for. We're using it to compare it to your data to give you some kind of context. Yeah.
Okay, so like for the error part of it, so you
Let's talk about error in a minute. Well, okay, I know everybody wants to talk about error because I know there was a lot of error in the lab, and that's fine. But let's get to the error section. Are we good? So that's kind of the goals of those sections. Now the hypothesis should be pretty simple. If you did the background and you did the experimental design, then the 3 hypotheses are just if-then statements that are based on those, right? So 1, if-then, what do you think is going to happen? 2, if-then, what do you think is going to happen? And then 3, if-then, what's going to happen?
What's this for?
This is for your hypotheses, right? Right? I printed this out for a purpose. All right. When you write your hypothesis, it has to be in some kind of testable format, something that you can. Everybody knows this is what you're. If this happens, that's what this means. That, and if that happens, then this is what it means. It has to be clear. There's no questions. If it's ambiguous, if it's not testable, if there's nothing we can measure, then it's not science, right? Or at least it's not hard science. All right, so now our data table. I think that's your hypotheses. I think that's clear. I don't think it's. It shouldn't be confusing. It might be, but it shouldn't be. But let's talk about. Oh, jeez. All right. So you need a data table. You need that. Now, how are you going to do this data table? Let me be clear, and I will. There's kind of 2 ways you can do it. You can do it by doing it in Google Sheets, or it's 3 ways you can do it, right? You can use Google Sheets. You can use,
I said you taught us how to do Google Sheets and stuff.
Yeah, but I'll show you again. In Google Sheets, you can use Microsoft Excel. Or you can just do it by hand. I don't care. You don't remember how, you don't know how. I don't mind you doing it by hand. So let's go through the process of what is it going to look like. Well, you're going to have your data table. You're going to have, what are the two things you measured? What did you do? What are you measuring?
Way back.
So we had days, right? I made the data table up on the board, right? You had day 0, which is the first day you did it. When you first waited to put it into the solution, that's your day 0. When did that happen? I don't know. For some kids, it was the last day of the lab because they were absent. For some kids, it was the first day of the lab. For some kids, it was the third day of the lab. Whatever. Everybody started at different times because they were late or they were tardy or they were absent or what have you. But you had day 0, you had day 1, you had day 2, you had day 3, and you had day 4. 4 days. Actually 5 really, but 4 days at least, the max. That's the most number of measurements I've seen over 5 different days. Then your group, so you had group 1. Let me use a different color just for visual sake. Group 1, which would be your group, right? Because you're the first group, the most important group as far as you're concerned. You had 3 measurements to make. You had your hypertonic, you had your
Which was
hypotonic, and you had your isotonic. And of course, for each of these, you had a measurement. A measurement of what? Mass in grams, right? That's what you measured, mass in grams. So for day 1 or day 0, you had some measurement. I don't know what that is, whatever it is. You had it. Let's say it's 20 grams. This one's 21. This one's 30. The initial mass is the mass is not what's important. It's the change in mass is what you're interested in. And then you had some other number here, 15 or whatever happened, and the hypertonic expected to decrease. So let's say it was down 19, then 18, then 15, and then 12. And then here in hypotonic, you expected to increase, but it decreased a little. Maybe it was 20.9 and 20.8, and well, not 2, sorry. 20.9 and 20.8 and 20.7 and then 20.7. And then I'm just making these numbers up. Obviously, don't go changing your numbers. What you got, you got. You only got 2 numbers in the row, that's what you got. You're not going to get a grade by what number you get. It's how you explain it. So 30, 20, isotonic expected to stay the same, but now watch what happens with a lot of people's data. They go 30.4. I'm confused. I thought it was supposed to stay the same. It went up. This one, then the next day was 29.4, and then, or, not 0.4, I'm sorry, 29.8. And next day was 30.0, and the next day was 29.7. So the question always comes up, well, that does, people say that doesn't make sense. Actually, it makes perfect sense that this is the kind of data I would expect to see. I wouldn't expect to see the same exact measurement every day on different days from people who have never really used this equipment before. I expect to be a little bit variation from day to day. All right, so we have isotonic, so that I expect there to be some variation, and this is what that plus or minus 0.4 means. That this is as accurate as some people's masses changed by a whole gram on one day or the other. It's like 30, 31, 30, 29, 29.1. So it kind of went up. That's because you weren't accurate you weren't very precise with your measurements. You weren't very precise with your measurements. Maybe you're just not used to the balances. Maybe you weren't drying the outside of the bag properly. Whatever. So make sure you're getting that straight. And then here you have group 2. And then you're going to have group 3. You're going to do the same thing. You're going to get the same data. So you can have this big old table with this data from at least 3 groups, preferably 4, 3 more, preferably 3 plus yours, so 4. But if you only have 3, that's fine. Whatever you have, you have. But these should be also the hyper, the hypo,
Oh, you talking like group,
and the ISO, right? For each of those groups, and that data should be here, right? So you should have numbers here all over the place. Does that make sense? Now, how are you going to, well, Mr. Mendoza, I don't understand what am I supposed to do? Well, you should have a row, bless you, at the bottom, at the very bottom of all your data, you should have an average, right? An average. So you should, however many groups you had, however many groups of data you had, you should add all of them up, add this one plus this one plus this one plus this one, this, and this, and this, right? Let me be clear, average for each of the, and you shouldn't add all those together, so I misspoke. You should have the hyper average, right? So you should take all the data from the hyper here, plus the hyper here, plus the hyper here, add them together and divide by 3, right? So take the information, the mass from day 0, hyper mass, you're taking the average of the hypertonic mass.
what group you talking like?
For this group, for the 3 that you should have data for at least 3 groups. Before you leave here yes, other groups. Group 1, group 2, group 3, add them together, and you should have a number. Let's say the average here, the average mass, whatever that average mass was on day 1, what was then on day 0, what was the average mass on day 1, on day 2, on day 3, and on day 4? Yeah.
Can we do averages from like other classes? Like, can we get the data from?
Yeah, I don't care what. I don't care where you get it. You can get it from other classes, or people in this class, whatever you like. But you might decide to do something else. There's another way you can do it. Is you can calculate the change in mass from day 1 to the final day. How would you do that? How would you find the change? You subtract the first day from the last day, so final minus initial, and that's what this delta means. This is delta, the Greek letter delta. It means final minus initial, so subtract those two and there'll be a number here. So you could take these numbers for all 3 groups, right? Number 1 from group 1, your group 2 from group 2, and the third, and then take that average. So then you could take the average change in mass, and you could graph that for the average. But the problem with this, taking the average change for hyper, it's not going to be easily graphed. So I wouldn't use. You can do that, but it's not going to be easily graphed, right? So that's why I tell you to go ahead and take 1, 2, and 3, add them together, and put it on day 0. Do that across, and then that way you can graph the average on a graph. So what do I mean by graphs? Let's take a look. That's the next step. So you're going to create a graph, and you see I gave you graph paper in your sample lab report. You take your graph. Again, you can do it in Google Sheets really easily.